Okay, so today we're going to begin our test review. Now, the packet that you picked up is the key and worksheet 2. We're not going to do that right now. We're going to do the test review in the packet. And then the worksheet 2, I'll save for tomorrow. If any students are here tomorrow during our abbreviated schedule, and also Wednesday morning, if you want to come in for a help session at 7:30. The key for this test review is in your packet or in the handout that you picked up. But try to go through as much as you can. And you want to practice without a calculator. Everyone should have. Okay, everyone should have a unit circuit. Let's see, say it again. Yeah, the other review sheet is in the packet. In this unit packet. Yeah. So the unit packet has worksheet review, test review 1, and then the handout you picked up has the solutions for test review 1, worksheet 2, and the solution for worksheet 2. If you want to, you can practice your unit circle on the back of the one you filled out. So on the back, if you want to do some more practice with unit circle, you can do that. But if you want to pick up some additional ones, I'll have them up here.
Under.
How about for now, let's just work through the odds so that we can make sure that in class we can kind of hit one of every type of problem. Yeah, so let's just do the odds. So go ahead and start. I will go through some problems with you, but I feel like a lot of these are just review. We should want to kind of get some reps with these. Okay, so start with the packet.
Okay.
Oh. Yes.
And for some reason, I can't figure out how to do that.
What, it's 360 minus 35, and then just whatever the results are.
You're supposed to use your boots.
For number 3, when you're finding distance, I will give you the formula. I'll leave that on the board, but the thing that we have to be careful about is, like on the quiz, if the thetas are not the same form, you have to get them into the same form. So either both degrees or both radians, but I can't have one degree and the other radian and use this formula, right? So number 3 and 4 are both nicely set up for you, but remember on the quiz, if one was degree and the other is radians, you want to make sure that they're both the same, either degrees or radians, before you use the distance formula.
Number 3, how are you supposed to get the decimal?
Right. If this was yeah, for non-calculated question, you would just leave your answer in this form. Or if it is still a unit circle value, you would just go as far as you can go, but you just have to leave your answer unsimplified.
But then how do you find the distance, because it's asking for the distance?
Yeah, so you can leave your answer in this messy form if you wanted to, because this is the equivalent, right? It's just a decimal version of that messiness.
If you add those two numbers, should you add a 36 to 16? That's maybe the most simplified. Because we,
Yeah, so 52,
Yeah,
and then,
but I won't take off points if your answer is unsimplified, because without a calculator. The only thing I want you to do is, if it was, future problems that has like cosine of pi over 2, I want you to reduce that down to 0 using the unit circle values. Yeah, some of these problems are calculator and non-calculator, so I think the worksheet 2 is a better model for what to expect on the test, since everything is purely not calculated on that. So that's fine, that's fine. Are you okay with number 1, order pairs? We know that we're either -4, 135 is in the 4th quadrant, so every order pair you're given is all dealing with the 2nd or the 4th quadrant. I think 5 and 7, however, are good problems for you to see how you can do without a calculator. So number 5, it says convert the rectangular coordinate into polar coordinate. So I have my x and y value. I want to get into r and theta. So I have to use Pythagorean theorem. Just get to r, and then I have to use inverse tangent to get to theta. So radius for number 5 is Pythagorean theorem, a squared plus b squared. Leave it in as root 18 or 3 root 2, either is fine. Inverse tangent, 3 over negative 3. You know that this is in the second quadrant. Inverse tangent of negative 1, another way of saying where is tangent equal to negative 1, you know it's in that 45-degree family. So second quadrant, that's 135 degrees. Use your unit circle. 135 degrees in terms of radius is 3 pi over 4. You don't have to go through this conversion because if you use your unit circle, you know that 3 pi over 4 matches 135. Yeah,
Can we just leave it in square root of 18?
that's fine. We can. Yeah, you don't have to reduce your radical. Right, so inverse tangents of negative 1. So it's basically asking where is tangent equal to negative 1? And if you use your unit circle, tangent is going to be 1 or negative 1 in that pi over 4 family, right? Because they cancel each other out. But it's going to be the second quadrant. So we want it to be 135 degrees or 3 pi over 4. Yeah, this should be odd so we can hit everyone, every type of problem. Okay, everybody okay with 7? Right, cosine of 210, sine of 210, find that on your unit circle. Get it down to ratios and multiply that 14 through. Okay, next page. Okay, a lot of the second page are just problems that you demonstrated, or the skills you demonstrated on the check-in quiz. So you're just going to add like terms and then you're going to build your complex numbers as vectors. So 3 plus 2i start at the origin over 3 up 2. And then plus, that means you're going to go right 1 down 5, and then your resultant vector will be the same as if you were to add those terms together. Distance is the magnitude of z1 minus z2, and the midpoint is z1 plus z2 divided by 2.
You just find the research, to do the change and take this.
Same. That tangent to the direction. Great answer sometimes. Yeah. Yeah, good. Yeah, probably try to break it. So there's a mismatch here, like what you do. This is complex numbers. Everybody okay with graphing distance and midpoint? Most guys did really well on the checking quiz, so hopefully that it's just a slight review. Okay, 15 and 17. Pythagorean theorem will get you to your radius or your modulus. Argument is just theta, finding using inverse tangents, making sure you're in the correct quadrant, and then putting the polar form, which is r bracket cosine theta plus I sine theta. You can use shorthand form if you want, but I think the original form feels more descriptive. It's up to you. Right. You're gonna kind of just make an estimation. Yeah. Yeah, the accuracy, it's not, the accuracy is not that important, as long as you know which quadrant you're in.
What kind of formula do you think?
You put it into. It's, well, give a calendar on you. It's with.
Like, yeah.
The fuller form, yeah. Yeah.
We have to memorize one.
They go through the same thing.
That's what
I write it out.
And we're both. So basically taking the art data and putting it into a format. Sorry, guys, it did ask for polar form, but it got, pushed to the next page. So if you go to the top of the next page, you'll see polar, category. I just didn't, get onto this page. I should have. Yeah, sorry, should have, yeah.
What's so the one that's highlighted is the one that you're ending up with?
Yeah, so if you go to page, 31, you see at the very top, it says polar. That should have been at the bottom of, so it should have said polar next to it.
Are
Right. So, if you go to your calendar, want to make sure you guys are clear with all the categories. So for rectangular form, for real numbers, just X comma Y. For rectangular form for complex numbers, I gotta do A plus BI. Polar form for real numbers, just R comma theta. Polar form for complex numbers will be this R cosine theta plus I sine theta. So again, we're working through the odds, and then we're good with this page. Let's go to page 31. We'll do 19 down to 27. Again, just go through the odds. For 19, converting from polar to rectangular form. Just have to distribute that 4√3 through, then we can get our horizontal and vertical components and put it into A plus BI form. Okay, for 21, 23, 25, you're practicing the different operations involved with complex polar numbers. Remember, with multiplication between polar, you're gonna multiply your radius but add your thetas. For division between complex numbers, you'll divide the radius, but then you'll subtract the thetas. And then for powers, you're going to raise the radius to that power, but then you're gonna multiply. And I put all these in shorthand form, but you can write them out in expanded form. That feels more comfortable.
Yeah, I think it's gonna do. So.
For these problems, are we supposed to like do them in doing, or do we just simplify it down to the A plus BI form and then solve
Oh,
for like
it
the,
says simplify, answer your polar form.
so keep it in the.
Yeah, we keep it with R and theta. So polar means you have R and theta in it. If it's rectangular, then A plus theta. So yeah, just use your directions. Okay, after you guys get through 21, 23, and 25, I do want to walk through 27 with you from the very beginning, because I know that the roots are the ones that is the most involved, because there's so many steps to it. Yeah. So Mr. When you, we follow this formula, we want to multiply.
Yeah, I tried to add these two and I got that.
Probably 6. Oh, 8 to 20.
So that doesn't.
19 and 12. Yeah, so.
Yeah.
Okay.
That
Yeah,
doesn't-
just leave it as 19 over 12, yeah, it's 19 pi over 12 is within the range from 0 to 2 pi, so that's safe to believe it. Change few time, it's one day. Have to subtract because it's outside the interval. You gotta get
And then
It's fun to write it like this and not short.
Exactly, yeah.
it is CIS.
CIS is a shorthand form of writing the same thing here. It's just less. The same thing as this. It's just RCIS, just taking this. But I just always, because we're comfortable with the longer form, just leave it at that.
Oh, so I don't have to break it down.
You do, yeah. So I have the extended form on the board here. I think this is the form that we're more comfortable with, so I don't want you to go through the shorthand form if you're, it is less writing, but this feels more descriptive, right? So this feels safer, but if you write the shorthand form and you know what it means, I won't take up any points, I just.
And then I don't have to put it in rectangular form.
Right, because it says answer in polar form. So that means you want R and theta in your answer.
Okay.
Give you guys another few minutes, make sure you're comfortable all the way up to 25. You can go ahead and try 27 on your own, but I will walk through 27 with you from the very beginning, because it's just more there. Okay, are we okay? 21, 23, and 25. So, yeah, just absolutely understand that the operations for radius is different than theta. Radius is gonna follow whatever operation you see here, either multiply, divide, or raise the power. But for theta, it's a little different. So we're gonna be adding the thetas here, you subtract the thetas here, and then here you're going to multiply your theta by n. 23, we have to make an adjustment. You're getting a to the power of 12, but that's not quite in the range that we want. So we got to add 2 pi to force it into something between 0 and 2 pi. Okay, 27. 27 says find the fourth roots of z This one is a little bit easier because it doesn't give it to you in rectangular form. If it was rectangular form, let's say if it was like 3 plus 3i, then I have to find r and theta using inverse tangent and Pythagorean theorem. But here, it's already giving you your r and theta, so you can jump directly into your rule. So the rule says, take r, take theta, and go through those operations. So we're going to raise 3 to the 1/4, and then you'll multiply your theta by 1 over n. So 1 over 4. We know it's 1/4 because it says find the fourth root. So fourth root just means 1 over that n value. If it's third root, then it's 1/3. If it's fifth root, then it's 1/5. Multiply that through, and that's going to get you the first solution. So your first solution is 3 to the 1/4 cosine of pi over 3 plus I sine pi over 3. We don't distribute, we leave it in polar form. That's the first solution. How many more do we want? 3 more. We want a total of how many solutions? 4, right? So it's fourth roots. So anytime you see a root, we got to find multiple solutions. So we got to go through our pattern. Our pattern is 2 pi over n or 360 over n, depending on which whether you're in degrees or radians. Right now we're in radians, so 2 pi over n, 2 pi divided by 4 is the same thing as pi over 2, which is 3 pi over 6. That allows me to at least match my common denominator. Pi over 3 is same thing as 2 pi over 6. So if I do 2 pi over 6 plus 3 pi over 6, that will give me 5 pi over 6. That will give me my second solution. I do need to find a common denominator between my original theta and my pattern so that I can go ahead and go through that adding process. So 2 pi over 6 plus 3 pi over 6 gives me 5 pi over 6. And then 5 pi over 6 plus 3 pi over 6 is 8 pi over 6. 8 pi over 6 plus 3 pi over 6 is 11 pi over 6. So we have our 4 solutions sitting here. I'm sorry, I don't think I put this solution page in the packet or in your handout. So, but it's on my website. I will send you the link so that if you want to practice to the even problems on this worksheet 1, you can do that. And then I encourage you guys to go through worksheet 2 as a way to review for your Wednesday test. Okay. Tomorrow, it's a shortened day, but if you're here in class, and you want to work, we can have you practice through additional prop or just go through the review handout, either worksheet 1 or worksheet 2. So I'm not going to give anything new tomorrow. I know not all of us will be here tomorrow, but if you are, we're just going to practice preparing for the test. And then Wednesday morning, I will go through 7:30. I will go through worksheet 2, but you guys have everything in front of you, so I encourage you guys to practice on your own, go through unit circle, memorize your formulas, look at the back of your calendar. Those are the formulas you're responsible for. I will give you the business formula up on the board. I'll leave that up on the board. Okay, don't forget your phones.
Go to the other side.
Yeah. Oh, the previous page?
The last one, like 21st, 27th.
Oh, okay.
Oh, very good.
No, I can put it here.
Yeah, no. Actually, so I think.
Yes, that's correct. Oh, yes. Yeah, check. Because I remember putting something on your belt.
Sometimes you can put your phones on Christ. Right now, Yeah, we can talk about, it's all right now. It should be. I know, right? Oh, it's never safe. Oh. Change.